Hi guys, in this video we're gonna be looking at how some of the trig functions like tan, sec, cosec were named, and in doing so we're actually gonna find that not all mathematicians were idiots, because the ones who named these functions actually knew that tan x is actually related to a tangent somehow, and we're gonna find out that stuff right now. So first off, you have to draw yourself a unit circle, which I've done here. This is a unit circle as it has radius 1, and after that you have to draw a line from O, and it just has to intersect the circumference of the circle somewhere. So now we just drop a perpendicular down from there. We know that this is 90, this we'll call X, and let's call this point A and that point B. Alright, so first off, I'm gonna prove that cos x is simply sine 90 minus x. Alright, so let's say sine x is AB, which is this length, divided by OA, which is 1. So we get that AB is sine x. Now we get that sine of 90 minus x, which is this angle, is simply OB divided by this length, which is again 1, OB over 1, which is OB. Now we can say that cos x is adjacent, which is OB, divided by hypotenuse, which is again 1. So cos x is OB. Therefore, sine of 90 minus x is simply cos x. And this actually makes sense because the cos x actually stands for cosine x, which in turn stands for complementary sine x. And if you think about it this way, then obviously it's cosine x is the complement of sine x. Say you have an angle over here, so let's call this x, then this is 90 minus x, and therefore both of them are complementary. Alright, so now let's move on to bigger things. Now, in order to prove that tangent is sine x over cos x, we draw a tangent at x equals 1. Then we extend this line OA such that it intersects the tangent somewhere, which it does. And now we're gonna say that, let's call this point C and this D. This length CD is defined as tan x. It's not defined as sine x over cos x, it's just defined as tan x. And if it were defined as sine x over cos x, why call it tan x in the first place, right? So now we're gonna say that, oh hey, look, this angle is 90, this angle is the same for both of them, therefore these two must also be the same. And therefore triangle OAB and OCD are similar. So now we can deduce that CD, which is tan x, CD divided by this length OD, which is 1, is the same as AB, which is sine x, divided by OB, which is cos x. So we end up getting tan x is sine x over cos x. Now we're gonna prove that OC is actually sec x. So let's start by saying that OC is OC divided by this length OD, which is 1, is the same as OA, which is 1, divided by OB, which is cos x. So we end up getting OC is 1 over cos x, which is sec x. And it actually makes sense again, because if you extend this line, then you see that it's gonna intersect somewhere around here, I guess. Yeah, somewhere around there. And a secant is simply a line which intersects the circle at two different points. And as you can see, it is intersecting the circle at two different points. So now we knew that mathematicians weren't idiots, and neither were they liars. So now we can actually go on to prove cotangent x. Alright, so let's draw a tangent at y equals 1, and then we extend this line OA to intersect this new tangent. And let's call this point D. No, we already have used D. Let's call it E, and let's call this point F. this is a 90-degree angle, as you can see, and FE and OD are parallel, therefore this angle is also x, and hence this angle is 90 minus x. So what does cotangent x actually mean? Well, it simply means tan 90 minus x, right? So let's look at it this way, right? Let's say that FE, I'll write it down, FE divided by this length, which is OC. No, let's take OF, it'll be simpler. OF, which is 1, is the same as this length in OCD, which is 1, divided by tan x, this length. So we get FE equals 1 over tan x. Therefore, we've just proven that cot x is 1 over tan x. Because this is cot x, this is a complement of tangent x, because it's tan 90 minus x basically, right? Opposite over adjacent, right? We can write it like this. Let's see. We can say that tan 90 minus x is opposite over adjacent, because we just proved that it's sin x over cos x. Opposite FE divided by adjacent, which is OF, which is 1, is equal to FE. Therefore, tan 90 minus x is equal to cot x, which in turn is equal to 1 over tan x. Now, the last thing that we're gonna prove is OE. OE is actually cosec x. So let's use the same logic. Let's say here OE is cosec x, which is sec 90 minus x. Now, as we just found out, sec is simply the opposite of cos, because it's 1 over cos, right? As we proven here, 1 over cos. So now we can say that as cos is adjacent over hypotenuse, sec x is gonna be hypotenuse over adjacent, which in turn is OC divided by adjacent, which is 1. And so we get that sec 90 minus x is OC, and hence sec 90 minus x is equal to cosec x. Basically that was the video. I hope you guys understood it and enjoyed it. Some feedback would be very much appreciated. Thank you. Have a nice day.